So section 5.7, we're going to look at some other techniques of integration. And we're going to evaluate what's called a trigonometric integral. Let me give you a moment to copy that down. Copy the example down, I should say. Okay. Okay, so trigonometric integral. And this notation here just means the cosine of x to the 5th power. So what you're computing here is the integral from 0 to pi over 2 of the cosine of x to the raised to the 5th power dx. And as you know, for definite integrals, you're always computing the area. Well, what you're doing is you're computing the area underneath the curve, cosine of x to the 5th power. You could put that in on your calculator, right? And you're trying to find the area underneath that function, bounded above, the area bounded above by that function, below by the x-axis, between the x values of 0 and pi over 2. You think, incidentally, this area, you think this area here, and I should probably have this down a little more, right? But is this area here positive or negative? What do your instincts tell you? Because sometimes area is negative, right? Sometimes definite integrals give us negative values. Positive is correct. Excellent. Excellent. Eric, Felicity, Rodrigo, Michael, Nabel. That's right. Because if you think about the cosine of x, if you graph that function between 0 and 90 degrees, between 0 and pi over 2, all the area is positive. Okay, all the area is positive. So if you take that positive area and raise it to the 5th power, you're gonna get then a positive answer. So it's helpful sometimes to think think about whether your answer is reasonable or not. It'll be helpful, for instance, you know, on exams, because exams, I mean, I'm still working on the exam, but you know, you might not have unlimited attempts, right, on an exam to get the answer right. So it's helpful to think about what what answer makes sense. But all right, so okay, so this is a trigonometric integral, and it's should be clear, reasonably clear, that a substitution isn't going to work. And man, integration by parts, I don't even want to try that here. So I gotta do something. Got to do something here with that cosine of x to the 5th power. Got to do something with it. And what I'm going to do is I'm going to write the cosine of x to the 5th power as cosine squared of x times cosine squared of x times cosine of x. I can take the cosine, the cosine of x to the 5th power. I can write it as the cosine of x quantity squared times the cosine of x quantity squared times the cosine of x, which is just, in terms of notation, cosine squared of x times cosine squared of x times cosine of x. So let me let you write that down. Okay, so now a good question needs to be asked: why do this? Why take the cosine of x to the 5th power and factor it out the way I did? Well, of course, we have to keep in mind we're doing what we need to do to try to determine this integral. And I like cosine squared of x because I have a trig identity that uses it. Sine squared of x plus cosine squared of x equals 1. That's called the Pythagorean identity. How many remember that from trigonometry or recall it, seeing it? Okay, Adriana, Michael, Eric, Hindi. All right, Esther, Rodrigo, Shalom. And I bet you thought, man, I'm never going to see that again. Won't need to use that again. Oh, not quite, not quite. We're going to need to use it here. Because you see, even though I factored cosine of x to the 5th power as cosine of x squared times cosine of x in this step here, I still can't integrate it unless I have a sine of x in there. And you'll see why. So what I'm going to do is I'm going to replace the cosine squared of x terms with 1 minus sine squared of x. Okay, I'm gonna replace the cosine squared of x terms with 1 minus sine squared of x. So I'm rewriting the equation in a special way. I'm sorry, not the equation, rewriting the integral. I'm rewriting this trigonometric integral in a special way. Now, at this stage, what's going to make more sense to do? A substitution or integration by parts? What's going to make more sense here? Definitely a substitution. We always want to try to do the easiest thing if we can. Okay, so Rodrigo and Tina said substitution. Well, all right. What would we let u equal? What might we let u equal? Yes, that's right, Rodrigo. Let's let u equal the sine of x. If we do that, then our integral, well, we let u equal the sine of x. You know, we're trying to make the integral easier to work with. Then du dx is cosine of x, so du is cosine of x dx. So what happened is now I have here 1 minus u squared here. Times 1 minus u squared there. And then cosine of x dx just becomes du. And this will bring us down to this here, the integral from 0 to 1 of 1 minus u squared times 1 minus u squared du. Oh, and the limits are 0 to 1 because the sine of 90 degrees is 1, you know, and the sine of 0 is 0. Right? So it's the sine of pi over 2. So, I mean, I don't need to put this in here, but, you know, it's okay. So now the question is, do we have an integral? This integral here, is this something that we can work with? Well, we have a binomial 1 minus u squared times another binomial 1 minus u squared. I mean, it still doesn't look pretty, but what can I do with two binomials? What have you learned how to do? I'll give you a hint. The first letter is F. It's a 4-letter word, not a bad word. Esther, almost, that's a 6-letter word. There we go. That's good. There we go. All right. Good deal. Good deal. All right. You could actually factor the 1 minus u squared into 1 minus u times 1 plus u, but it wouldn't really help us. I'm just going to FOIL this. I'm just going to FOIL this so that I'm going to get an integral of a polynomial. And we can handle an integral of a polynomial. Okay, give you a moment to copy that down. Okay. Are there any questions? You know, so FOIL, first, outer, inner, last. The one comes from multiplying the first two terms. The first terms, 1 and 1 is 1. And then the outer minus u squared, that comes from multiplying the minus u squared on the outside here times the 1 on the outside there. Okay. And then the inner would come from the minus u squared here is going to come from taking the inner term minus u squared times the inner term 1. And then finally, the last term, u to the fourth, comes from multiplying the last two terms. Minus u squared times minus u squared is u to the fourth. Okay, and that's all. That'll be in the recording, of course. So then let's move to the solution.
Professor.
Yes. I'll go back here. Hold on. Yes, Esther. Yes.
I have a kind of dumb question because just letting you know, I didn't finish my high school here. I just made my, I'm from Brazil, so FOIL
Okay.
means, I'm sorry to ask this, but FOIL means basically I'm gonna multiply
first.
What?
So this is the way that, at least in many American schools, they like you could use distributive. You could take 1 minus u squared and multiply that by 1, and then multiply that by the negative u squared.
Oh, I see.
And that's another way to do it. But when you do it, you'll get FOIL is just a sort of a technique that students learn in a lot of like American schools. I mean, I know it's taught a lot in our high schools here. You multiply the first two terms, 1 and 1. Hold on here. 1 and 1.
I see. I get it.
Oh, you're good. Okay.
Oh no, because I just didn't know the meaning of FOIL, because
Oh,
I thought
sure.
FOIL was not. I don't know.
It
I'm
stands
so sorry.
for no problem. First, outer. FOIL means first, outer, inner, last.
Oh, okay, I got it now. Thank you. I'm sorry for my
That's
dumb
okay.
question.
No problem. No problem. There are no bad questions. It's a good question. All right. So we're going to combine these like terms, negative u squared and negative u squared. And now it's just, this is like a calculus 1 antiderivative. The antiderivative of 1 minus 2u squared plus u to the fourth, that's antiderivative of a polynomial. So that's calculus 1. And you just finish out the problem. All right, and you will arrive. Let me see. Hold on here. You should get a final answer of 8/15 when you're done. Absolutely amazing. And you know WebAssign wants, thank you, Tina. WebAssign wants the exact answer, simplified radical form. Unless it tells you approximate with a decimal, you'll want simplified radical form. All right, are there any questions? Are there any other good questions? How many kind of liked this problem? Thought it was kind of a cool problem. I hope maybe I get one thumbs up, but maybe. Okay. Snegus, maybe. Justice has a thumb up. All right. Tina's cool, maybe. Adriana. All right. Very good. Yes, Michael, interesting. Eric, yep, yep. All right, so what I want to do, let me stop the recording now.